The slides are for part 3 of set 4. In this presentation, I'll talk about tabular method. Tabular method is a way to minimize the cost of digital circuits. This method is also known as the Quinn-McCloskey method. It closely follows the procedure described near the end of part 3 of slide set 4 and has the same steps. The method can be easily programmed and run efficiently on computers. The basis of the tabular as well as K-map method is the combining property of Boolean algebra, and the combining property is shown here. We will use the following function to explain the tabular method. The function has these min terms. The first step of the tabular method is to generate all the prime implicants of the given function. This is done by creating one or more tables in sequence. Each table will have a list of implicants. The very first list, list 1, is in the first table, and in list 1 we write down all the min terms of the function for which the output is 1 and group the min terms based on the number of ones in the binary representation of their indices. For example, 4 and 8 have only 1 in each of their binary representations. Hence, min term M4 and M8 are in the same group. This is shown in the next slide. In list 1, min term M sub I is denoted by its index I only. If there are any don't cares for the function, then they are also listed like min terms in list 1. For each min term, we list the corresponding implicant, and this is in the rightmost column of list 1. For example, for min term M13, the corresponding implicant x1, x2, x3 prime, x4 is listed as 1101. 0 for complemented form of the variable and 1 for uncomplemented. In list 1, there are 4 literals for the function under consideration in each implicant, and these are just for short indicated as 4L implicant. In general, however, if we have a function of n variables, then list 1 will have n literals in each complement. List 1 that I mentioned in the previous slide is shown in this table. The leftmost column of this table has number of ones in the binary representation of the indices of min terms. For example, this row corresponds to number of ones, and number of ones is 1 for the binary representation of 4 and 8, meaning that the corresponding min term is M sub 4 and M sub 8. And on the rightmost column, I have the 4 literal implicants for M sub 4 and M sub 8. Since we are considering a 4 variable function, that means the maximum number of ones we can have in the binary representation of indices of the min term is 4, and we have only one such min term, that means min term M sub 15. And the corresponding 4 literal implicant is here. Once the list 1 has been prepared, then we combine implicants of one group with implicants in the preceding group that differ in 1 bit location only. The resulting implicants have 3 literals each, corresponding to a rectangle covering two squares in the K-map. For example, we can combine this implicant with this implicant, and the resulting implicant is a 3 literal implicant, and this is denoted as 1x00. X is to indicate the place location where the two implicants that we are combining differ. We enter all newly formed 3 literal implicants in list 2, and this is shown later on. 4 implicants that are part of 3 literal implicants are checked off in list 1. For example, here when we have combined these two implicants, we put check marks here and here. Going further down, say we could actually check mark here because this could be combined with the literal in the top row. And so this could be combined with the literal that we have here. Similarly, this could be combined with the literal that we have again here. Going to the next row, this could be combined with the literal here because the difference is in one location. And we can continue this way. The implicants that we were able to combine in list 1 shown in the previous slide are part of list 2. Our list 2 is shown in the next slide, but here I have a couple of comments. For list 2, the leftmost column has combined mean terms. The right column shows corresponding implicants of 3 literals. For example, after combining implicants 000 and 0100, and this is from list 1, we denote the resulting 3 literal implicant as 0x00, and this is in the right column of list 2 on the next slide. And why we are able to do that? That's because this implicant is actually this product term, and this implicant is this product term. We can apply algebraic manipulation and write these two product terms as follows. And some simplification, that means this term in the bracket is equal to 1, that leads to this expression. So here 0 is to indicate x1 prime, then this is to indicate x3 prime and x4 prime. X is to indicate the absence of a literal x2. List 2 that I mentioned in the previous slide is shown in this table. The leftmost column of this table has the combined mean terms. For example, in list 1, we were able to combine mean terms 0 and 4, and that's why we have now this 3 literal implicant. We are also able to combine mean term 0 and 8, and that's why we have this 3 literal implicant. Note the way that I have formed these groups. So this row corresponds to the grouping that we have in list 1 in the top and the next row. And this grouping is from row 2 and row 3. And this grouping is from row 3 and 4. And finally, this grouping is from the last 2 rows of list 1. Once list 2 has been prepared, we combine implicants of one group with implicants in the preceding group that differ in one bit location only, making sure X's align. For example, we can combine this implicant with this because X's are aligned, and the only difference is in the leftmost location. Similarly, we can also combine this implicant with this because the X's are aligned and the difference is in only one location here and here. Each resulting implicance has two literals, as you can see here. Like when this is combined with this, we'll have another X and the second leftmost location. That means the resulting implicant will have two literals. And this corresponds to rectangle covering 4 squares or cells in the K-map. The three implicants that are part of two literal implicants are checked off in list 2. So when we combine this implicant with this implicant, we put check mark here and here. Similarly, combining this and this implicants would make us to put a check mark here and here. You can look at other implicants that we have in this table. You'll be able to see that none of these can be combined with any implicants in the preceding grouping. Here we have list 3. List 3 has the implicants that were checked off in the previous list, list 2. The left column of list 3, again just like list 2, indicates combined min terms. The right column shows corresponding two literal implicants. In this example, list 3 has only one combined min term and its implicant. Here, x000 and x100 from list 2 are combined, and the resulting two literal implicant is xx00. Once list 3 has been prepared, we combine two literal implicants of one group to the appropriate implicants in the previous group that differ in one bit location only, making sure x's align. Well, for this example, we have only one group and hence no opportunities for further combining. Implicants of any size that are not checked off in any one of the above lists are the required prime implicants. In our example, list 1, 2, 3 have 0, 5, and 1 prime implicants. In list 1, we were able to check every implicant. That means there is no prime implicants from that list. In list 2, we were able to check off some but not every implicants, and from that list we have 5 prime implicants. And in list 3 there are only one implicant, and of course that cannot be combined with anything else, so that is one prime implicant. The 6 prime implicants are reproduced below and denoted as P1, P2 up to P sub 6. In the previous slide, we saw that the function under consideration has 6 prime implicants. For a given function, when all the prime implicants are found, the next step is to find the essential prime implicants. So for our function, first we list all prime implicants and the min term that they cover, and this is shown in the table here. So we have 6 prime implicants. They are in these 6 rows, and this prime implicants covers min term M0, M4, and all the way up to M15 as shown here. Now, if you look at each row, okay, you will be seeing that there are some check marks, and those check marks indicate the min terms that the prime implicants are covering. For example, prime implicant P2 is covering min term M10 and M11. That's why we have check marks here and here. Once all the check marks are are placed, then actually we scan the table column wise and see okay, whether there's any column that has single check mark only. And that is the case for this column, and the corresponding prime implicant PI is P6. So P6 is in this case an essential prime implicant because this must be in the cover to include M sub 0 as part of the expression. Now if you scan the next column, here we also have one single check mark, but the corresponding prime implicant is already part of the cover. That means P6 is already covering M4. P6 is also covering actually M8 and M12. But if you look at all the columns, there is no other column, okay, other than this column and this column where we have single check mark. So for this particular example, P6 is the only essential prime. But P6 does not cover all the mean terms. So we need to find some other prime implicants to cover the mean terms that P6 is not able to cover. So in the next step, what we will do, we will remove P6 and the mean terms it covered and then try to find out those necessary non-essential prime implicants. After finding essential prime implicants, our next step is to find necessary non-essential prime implicants. We are in need to find such non-essential prime implicants because our essential prime implicant is unable to cover all the mean terms. So here we have a smaller table compared to what we had in the previous slide. In this table, we do not have row P6. Prime implicant P6 was covering a number of mean terms, M0, M4, M8, and M12. They're also not part of this table. So this table is much smaller than what we had in the previous slide. Now, if you look at row corresponding to P1, you will see that P1 covers only mean term M10. And if you look at row corresponding to P2, it covers both M10 and M11. So in this case, P2 is dominating P1. This is an example of row dominance. Similarly, between P3 and P5, you'll see that P5 is dominating P3. P5 covers both M13 and M15. On the other hand, P3 covers only M13. So we can actually remove the row corresponding to P1 and row corresponding to P3. And the resulting smaller table is shown in the next slide. So here we have a smaller table compared to what we had in the previous slide. Of course, here we do not have row corresponding to P1 and P3. Now, if you look at this table, you see that we must choose P2 as part of our cover because P2 is the only prime implicant here that is covering mean term M10 because of this check mark. Similarly, if you look at this column, you realize that we must have P5 as part of our cover because that's the only prime implicant is covering M13. Now, if both P2 and P5 are part of the cover, that means we're also covering M11 because of P2 and also M15 because of P5. And so with these two rows, actually we are covering all the mean terms that we needed to cover. So the final cover for this function is P2, P5, and these are non-essential but necessary prime implicants. And P6, that was actually discussed earlier, that is actually our essential prime implicant. And these three implicants together cover all the mean terms that for which the function has a value of 1. So the final expression for the function is shown here, is the logical sum of these prime implicants. and their expansion, that means their SOP form is shown here. Here I have another example for finding necessary non-essential prime implicants. So here we are given a table. This table is after finding the essential prime implicants for that function. So the table has only the prime implicants that are non-essential. And these non-essential prime implicants are to cover the min terms that I'm encircling. Now, if you look at column with the M8, you'll be seeing that there's a check mark here and here. Now, the next column, M9, has also check marks in the same row, okay, where M8 is having check marks. But M9, column M9 has additional check marks, in this case is here. So column 9 actually dominates column 8. Unlike row dominance that we saw previously, when there is a column dominance, then we remove the dominating column. That means in this case, we'll be removing column 9. Similarly, we'll be removing column 13, which dominates column 5. So after we remove these columns, then the smaller table is shown in the next slide. If you look at the table on left, you see that we do not have column M9 and M13. Now, if we look at row corresponding to P4 and P6, we see that P4 actually dominates P6 because P4 covers 2 min terms. On the other hand, P6 covers only one of them. Similarly, if you look at row 5 and 7, you see that P7 covers row 2 min terms and P5 covers only one of them. That means P7 dominates P5. Now, removing the dominated rows, we obtain a smaller table which is shown at the right. Now, if you look at the smaller table, we see that column M5 is covered only by P7. That means P7 is essential to cover min term M5. Similarly, if you look at column M8, you see that only one check mark here in this column. That means we should P sub 4 is essential to cover M8. But by definition, P4 and P7 are not essential prime implicant, but they are necessary so that we can cover M5 and M8. Now, when we actually include M4 and M7 as part of our cover, we also cover min term M0 and min term M7. So actually we could remove the columns that are covered by the two necessary prime implicants that we have identified. And the corresponding table, smaller table, is shown in the next slide. So here we only have 3 prime implicants as shown here. And among these 3 prime implicants, we see that if we choose P2 as part of our cover, then it will cover both M2 and M6. So final the cover is P2 that we have just picked from here, and P4 and P7 that we picked in the previous slides. So these are our necessary non-essential prime implicants to cover the min terms that we started with, I think 2 slides ago.